Okay, so today we're going to talk about how to use our calculators to help us calculate what is happening with our z-scores. So the very first thing we're going to do is we're going to go ahead and look at our calculators and look at what we need to know on our calculator. So let me go ahead and fix this. So there's my graphing calculator. And what you really need to know is that stat button. That's how we do all of our lists and stuff like that. And then we also have this distribution button. Since we're working with a standard normal distribution, we're going to hit second and get that distribution popping up. And now what we have is a normal PDF and a normal CDF. What we want all the time is normal CDF, because CDF is looking for a cumulative. It's looking at the shading in between certain values. And so for all of our sort of things, we're looking at normal CDF. So when you're showing your work using a calculator, you still should be, here, let me minimize this. You still should be drawing your kind of curve. And you should be kind of illustrating how, okay, this is my curve. I want it less than 0.58. So you shade. And then you go ahead and with your calculator notation, you say, okay, I'm going to use this normal CDF. And I want you to find my percentage or proportion between, and this is what we call a lowest bound. So we start with lowest bound, and that is the lowest value that I want here. And so in my normal curve, that's usually like right around -4, but to be safe, we always say just pick something really, really low. So I'm going to use -10 as my low bound. And then I want to know my upper bound. So this is the low bound on my shading. So low bound. And this is the upper bound on my shading. And that's my z-score, the 0.58. And so that's going to be my upper bound. I want to know the shading between -10 and 0.58. So upper. And you have to label these as lower bound and upper bound. It's one of those things for, if you're going to use your calculator to let you do the work, you have to at least tell us, what are you entering in on your calculator, so we know what's going on. And then the next thing we have is our mean and standard deviation. Now, because these are z-scores, or a standard normal curve, our mean is 0, and our standard deviation is 1. And that should always be the case. And so you have to have those labels below, those words below to do that. So now we're going to go ahead and take a look at our calculator. And my cable's getting all cut up on there. Let's see. So here's our calculator. We're going to go ahead and hit normal CDF. We're going to put in that lower bound, -10, our upper bound, 0.58. And you see that it's already set up for that standard normal curve of 0 and 1. It will remember the mean and standard deviation that you put in. So if you change this, it won't go back to the 0, 1. And then you hit paste. And it puts it in your calculator, you hit enter, and it tells you that proportion. And so up here, I can actually say that this is equal to that 0.7190. Now, it is your choice if you write it as a proportion or a percentage. But if you change it into a percentage and you make a mistake, you will get points taken off. So I tend to leave it as a proportion just because it's easier for me that way. So on the next one, we have z is less than -1.12. So this is going to be, again, a normal CDF. My lowest bounds, because I want it to be everything less than, is going to be just a really low number. You can even do -1000 if you want to, but -10 is low enough. And this is my lower bound. And then I have my upper bound of -1.12. and then I have my mean and standard deviation. And sometimes you can put the symbols here for mean and standard deviation if you like, and as long as your symbols are correct, it illustrates that you know what you're talking about. So then we're going to go back to our calculator. I'm going to hit clear. We're going to go back and do second distribution, normal CDF. My lower bound is -10. My upper bound is -1.12. And I have that mean and standard deviation. I hit paste, enter, and now I get the 0.13135. So 0.1314. Okay, so now if we're going to do greater than, so when I look at that curve, and we should be drawing curves for them all, but there's not a lot of room to write here. So I want greater than 0.26. So I'm going to kind of draw my line at 0.26, and I want to shade above. So now when I'm looking at this, I'm still using a normal CDF. But now the lower bound of my shading has changed. The lowest I want is at 0.26. So when I'm doing lower bound, I put 0.26. And then my upper bound is going to be something just really high. So I could go as high as 4 because when remember we look at that curve, we go out about 4 standard deviations. You could use 4, but I choose something higher, 10, because I'm too lazy to write 100. And then we put in our mean and standard deviation. So mean, standard deviation, and upper bound. And then we're going to figure out our value. So I go back to my calculator. And I'm not going to show you the picture because it makes my video actually take up more memory and space. So go to distribution, normal CDF, lower bound 0.26, upper bound is 10, mean is 0, standard deviation 1, and we get a value of 0.3974. And that's our answer. Okay, so I've showed you that whole notation up below it, but because we don't have a lot of space, I'm going to stop doing that. But that doesn't mean that on your quizzes and tests and AP exam that you don't write those. You still have to write those. And that's really, really important for you to remember. Okay, so let's go to the next one. Z is greater than -1.58. So this is going to be a normal CDF. Our lowest value is -1.58. Our highest value is going to be something really large, like 10. Our mean is 0, and our standard deviation is 1. So we're going to go into second distribution, normal CDF, -1.58, 10, 0, 1. And that tells me that it's 0.9429. Okay, so now how do we do this when we've got two values? So think about it just like we would with our shading. When I've got my curve, my lowest is -1.1, my highest is 0.26. I shade in between. And I've just really pretty much told you this is my lower bound and this is my upper bound. So for my normal CDF, my lower bound is -1.19, my upper bound 0.26, a mean of 0, and a standard deviation of 1. And so now I get 0.4855. And that's our value. So for our next one, we're going to do the same sort of thing. So normal CDF. And if you haven't been using your calculator at the same time, I highly recommend doing this to make sure that you're doing it right. Because you don't want to not practice this and then come to a test and have to fumble your way through this. So our lowest value is negative 0.58. That's my lower bound. My upper bound, 2.09. Standard deviation, or mean of 0, standard deviation of 1. Don't forget that's in the distribution menu. And I get 0.7007. Okay, so that's how to find that proportion with those curves, but now how do we work backwards? So now if I have the proportion, what does it look like? So remember, when I'm dealing with 20th percentile, I'm looking at 0.2 as my area, my shaded area. For 76th percentile, I'm looking at 0.76 as my shaded area. So we're going to go ahead and we're going to look at, well, how do I find this out? So remember, this is working backwards. So let's look at that calculator. So those are all those normal CDFs we already did. We're going to clear those out. And now what we're going to do is we're going to go ahead and let me make this a little bit larger so it's easier for you to see. We're going to go ahead and do second distribution again. And you see how we have the inv norm? That's inverse norm. And it's inverse because we're working backwards. So we're going to go ahead and select inverse norm. And the area that I want to find is 20% below the curve. And then I have a mean of 0, a standard deviation of 1, and I hit paste. Hit enter one more time, and that's my z-score. So now, down here, I would go ahead and write down exactly what I typed. So this would be an inverse norm. Helps if I spell norm correctly. My area, my mean, my standard deviation, and that gives me a value of negative 0.8416. So my z-score is negative 0.84. And if you wanted to draw a picture to go with that, I'm showing that this is about 20%, and I want to know this value, negative 0.84. So it just kind of gives you an idea. So let's see that again with the 76th percentile. So now I'm going to do second distribution, go down to inverse norm, and now I want 76th percentile, so 0.76 below the curve, and it tells me that z-score. So back over here, we're writing our calculator speak, inverse norm. Area is 0.76. Mean 0, standard deviation 1. And that gives me a z-score of 0.706. And so when you're drawing that curve, it would make sense. Yeah, it's about 76%. Okay, so now that we've talked about this in terms of just z-scores, just using our calculator, Now we're going to go back to, surprise, surprise, contextual story problems. If you ever forget how to do anything, this part of your notes shows you that normal CDF, where to find it, how to do the inverse norm, what are the values. So if you forget, those directions are right there in your notes for you. And because we use these so much, you shouldn't have to look it up because you should be using them all the time. Okay, so we're going to take this a little bit farther and show you how even more powerful this is. In 2008 Wimbledon tennis tournament, so we did this before, we did this with our table, now we're going to do it with the calculator. So Rafael Nadal averaged 115 miles per hour on his first serves, assume the distribution is normal. So we started off with 115, draw that curve. Ooh, that looks much better than before. So I've got 115. I go up by 6s and down by 6s. $121, $127, $133, $139. Okay, so we want to know what percentages exceed 120 miles per hour. So I go ahead and I draw my curve, I shade because that's the appropriate way to do your problem. And now we're going to go ahead and use our calculator. Now, usually we'd go to z-score and we could use our calculator from there instead of our table, but our calculator is more powerful than that. What we can do is I can say, I want to do a normal CDF, and based on my graph, my lower bound is 120. My upper bound is something really high. So I want to go way higher than 139. I'm going to go as high as 200. So this is my lower bound, upper bound. And then we're going to put in our mean. And our mean for this distribution is 115. And I'm going to go ahead and use the mu symbol for mean. So that way you're seeing it as that and as x bar. And then our standard deviation here is 6. Lowercase sigma. And so I can plug it in like that, and it saves me the work of having to change into z-scores because our calculator is just that powerful. So let's go ahead and look at our calculator and type in that information. So I'm going to go to normal CDF. I'm going to go ahead and type in that 120 lower bound. I'm going to go really high. I think we said 200 is an upper bound. Our mean is 115. Our standard deviation is 6. And it will calculate it for us. And that's our answer. Which is really close to the answer we got from the table. So this is 0.2023, which is about 20%. And that was the answer we got before. Okay, so let's look at it now. What proportion of his first serves are between 100 and 110? So I'm going to go ahead. There's my mean. Okay, that curve is horrible, but we get the idea. So we've got 115. And in the interest of time, I'm not going to write down the numbers. We're just going to go ahead and do this for down here. And we want to know between 100 miles an hour, which is right about here, and 110 miles an hour, which is right about here. So on our calculator, we're going to go ahead and we're going to do a normal CDF. And our lower bound, or the lower part of our shaded region, is that 100 miles an hour. Our upper bound, or the upper part of our shaded region, is 110 miles an hour. And then we have a mean of 115 miles an hour. That isn't an M, it's actually like a U with a little tail in front, by the way. And then our standard deviation of 6. So instead of showing you on the camera, because again, the more times I switch over the document camera, the more memory it takes up. So we're going to go to our normal CDF, enter in our information, and it's going to give me a proportion of 0.1961, which is really close to what we got with the table. We had about, with rounding, 20%. And that with rounding gives us about 20%. Okay. So now we're going to go ahead and look at one last story problem. And we have the heights of 3-year-old females. According to the CDC growth chart, the heights of 3-year-old females are approximately normal. So that's my key there, that I can now use a normal distribution with a mean of 94.5 and a standard deviation of 4 centimeters. What is the third quartile of this distribution? So let's go ahead and look. Let's see, we start at 94.5. We're going to have our curve. And we're going to go out by 4s. So 98.5, 102.5, 106.5, 110.5, and then I go down 90.5, and 86.5, 82.5, and 78.5. And we want to know the 75th percentile. So I'm going to go ahead and I'm going to kind of estimate. I know half is right here. And so I want half of my half added on there. So I'm going to say, let's see. So probably somewhere in here is going to be about my 75th percentile. So I want to figure out what is this value right here. And so because I'm working backwards, I'm starting with a percentage. This is going to be my area. So I'm going to work backwards. So I'm going to use an inverse norm. My area is going to be 0.75 for that third quartile, so 75% below. And then I'm going to have the mean. So the mean of this distribution is 94.5. And then I'm going to have my standard deviation, which is 4. And that's going to allow us to find that value that's at the 75th percentile. So we're going to go ahead and grab our calculator. We're going to go into that distribution. We're going to go to inverse norm, type in our values. And we get a value of 97.197959. So about 75% of 3-year-olds are shorter than what? Well, 97.2, because I rounded it, centimeters. And that's it. Now, keep in mind, on these word problems, to save you time, I went ahead and put your state, your plan, your do, and your conclusion. But most of the time, they're just going to give you this problem. And they expect you to do all of this on your own, all that writing. And so when it comes to free response, they're looking for this information. And if you don't do that, you will lose points. So the more you practice going through this, drawing your curve, shading, putting in your stuff, and then saying, what does this number mean? Well, about 75%. And that's where we're looking at, what are we asking? That state part gives us what information we have to work with, and what are we looking for? So if we can state it at the beginning before we get bogged down with all the math, then when it comes back, we can look at, okay, this is what I'm trying to find. So I'm trying to find about 75% of 3-year-old females are shorter than this number. And it gives me that whole context for that answer. Okay, so we're almost there. We're almost done with chapter 2.